Welcome to lesson 7.4, the side splitter theorem. Let's just get into what this side splitter theorem is, and it is this. A parallel line through a triangle, a parallel line through a triangle splits the sides of the triangle into proportional pieces. What do I even mean by that? Well, if DE, this line right here going through our triangle, is parallel to CB, what I would know for a fact is that the ratio of AD to AE, so AD to AE, would be equal to the ratio of DC to EB. These would be the same, all right? Well, how can we use this to solve some problems? Let me show you how. Triangle PQT with RS parallel to PT is shown below. RS is parallel to PT. All right, that's shown below. What is the length of ST? Well, to do that, we just set up a ratio. And as I said before, if we know these are parallel, we could say that these top parts, okay, 4/5, will be equal to the ratio of these bottom parts, okay? So 8 over, and we don't know what ST is, so let's put an X there. To solve this, we just cross multiply. 4 times X equals 40. To solve for X, we're just going to divide both sides by 4, and we get X is equal to 10. And that is our answer for ST. Beautiful. ST is equal to 10. 4 is to 5 as 8 is to 10. That makes sense. Beautiful. All right, let's try another one, okay? We'll get a little more tricky, a little more challenging on this guy. In the diagram below, triangle ABC, all right, let me zoom out a little so we can see this guy. Oh, whoa, too much. BA is parallel to ED. AE, right here, is equal to 14 inches. And AC, which is this whole guy right here, is equal to 21 inches. And finally, BD is equal to 6 inches. And BD is right over here. Find to the nearest inch the length of CD, which is right over here. This is our CD. All right, we'll put X there because we want to figure that out. Now, how are we going to solve this, right? Well, we know that these pieces are proportional, these pieces of the sides. The thing is, I don't know what this side length is right here. I just know that the whole thing is 21 and this part is 14. How can I figure out what this side is? Well, that would be easy. All I could have to do is subtract 21 from 14. So 21 minus 14 is equal to 7, right? 7 plus 14 is equal to 21, so yeah, that makes sense, all right? Now that I have each one of these pieces, all right, I could set up my proportion. And that is 7 is to X, right? And that's equal to 14/6. What we're going to do here is just cross multiply. X times 14 is 14X. 7 times 6 is equal to 42. We divide both sides by 14. All right. And we get X is equal to 3. Perfect. And like I said, do these seem proportional? 7 is to 3 as 14 is to 6, right? That is proportional, right? When we double 7, we have to double 3, and we get the same answers. Beautiful. All right, in the figure below, DE is parallel to AC. All right, so we know the sides are split up into proportional pieces. Find the value of X and the length of BE. Well, to get BE, we have to know what X is, so let's solve for that first. And let's just set up our equation. X1 plus 1 over X minus 1, X plus 1 over X minus 1 is equal to 10/6. 10/6. Okay, let's just cross multiply to solve. So we get 6 times X plus 1 equals 10 times X minus 1. To solve this, we have to distribute our 6 out. So we get 6x plus 6. And we're going to distribute our 10 out. And we get 10x minus 10. Let's go ahead and solve this guy. Minus 6x from both sides. We get 6 is equal to 4x minus 10. We're going to add 10 to both sides. Oh man, running out of space. We get 4x. That cancels, is equal to 16. Whoa, let's extend this page. Divide both sides by 4, and we get x is equal to 4. Whew. Now to find out what we want to find out what the length of BE is, which is right here. We're going to just have to plug in our 4. We found out that x is equal to 4. So to find out what BE is, well, that's just 4 minus 1. So BE is equal to, BE is equal to 3. All right, now for the second part of our lesson. If we know xy is parallel to AC, xy, which is right here, is parallel to AC, then we know that this smaller triangle, xby, which I took the time to show you right here, xby, which is the same thing as that we have right here, is similar to the whole bigger triangle, ABC. It's a triangle within a triangle, and they're similar. Whoa! Is there a way I could prove this to you? Well, yes, there is. And if we can just think back to something called parallel lines and what we learned about those things. All right? So xy is parallel to AC. Let's bring back some knowledge. Well, I know that angle A and angle X are corresponding angles. All right? Thinking back, those are corresponding angles. And if these lines are parallel, that means these two angles would be congruent because corresponding angles are congruent. Similarly, on the other side, I know that C and Y are also corresponding angles. And since this is a parallel lines, C would also be congruent to Y because corresponding angles are congruent. Now, if you're looking, bearing with me right now, okay, I'm going to say this. What kind of similarity can we prove with these two triangles? Angle-angle similarity. That's correct because we have two pairs of congruent angles. A is congruent to X and Y is congruent to C. Holy shnikes, we proved it. There's two pairs of similar triangles. I mean, this is a pair of similar triangles. That is so awesome. Look at that, looping back all our old knowledge. Cool. Now let's solve some problems with that. We want to find the length of AB and AX. And we're going to start with AB here. And we're going to do that by just transferring over our triangles to here, okay? Here's our smaller triangle and here's our bigger triangle. Now we know XB is 6 and we know XY is 5. And we know AC is 10 and we have no idea what AB is. So we're going to call that X. So to solve what AB is, we'll just set up our ratio. So 10, our bigger triangle, is to 5 as 10 is to 5 as X, which is our bigger triangle, is to 6. Don't make the mistake I just did. We're going to cross multiply to solve. Cross, cross. So 10 times 6 is 60. 5 times X is 5X. To solve for X, we're going to divide both sides by 5, and we get X is equal to 12. Cool beans. So that tells us that AB is equal to 12. All right, this whole thing is equal to 12. We solved that. Now the second part of this question is what is AX? All right, and that's just this part right here. And to do that, we're going to do like we did in the last problem, 2 problems ago actually. All we have to do is subtract 12 from 6, the whole thing from the part. This is like back from Unit 1. So 12 minus 6 gives us the smaller part, and that's just equal to 6 as well. So this side is equal to 6. So that makes sense. 6 plus 6 equals 12, and we are badasses. Moving on. In diagram of triangle HMP below, LV is parallel to HP. We know ML is equal to 3, LH is equal to 4, and who would write that? And LV is equal to 9. We want to find the length of HP. Well, I think we can do that. Let me just draw out these two smaller triangles. So we have our smaller triangle right here, right? This is our smaller triangle. And this is LMV. And then we have our bigger triangle, right? And this is HMP. Now these are my two triangles, and let's just fill things in. So I know ML is 3 and LV is 9. I know MH is this whole length. I'm not going to just write 4 because it isn't 4. It's 4 plus 3. The whole length is 7, right? And HP, well, we don't know that. So we're going to just put an X there. All right? That's the main key here. This is why people are going to get it wrong. Remember, if you want to know the whole length, you have to add 3 plus 4. Okay, now we just set up our ratios and solve. So 3 is to 7 as... Oh, you know what? Sorry, bigger triangle over smaller triangle. 7 is to 3 as x is to 9. We'll cross multiply and we get 9 times 7 is 63. 3 times x is equal to 3x. Divide both sides by 3 and we get x is equal to 21. So how big is HP? 21. Sweet. Well, guys, what can I say? We've learned a lot today. I'm really proud of you, and just keep on being you, a rock star from your heart every day. All right, guys, stay classy. Oh, wait, sorry, I'm going to say one more thing. Sorry, let me just say one more thing. 3, just to show that this is right. I know I don't usually come back. This side, 3 is to 9, right? This is the ratio of 3 to 9. Is the same thing as 7 is to 21, right? 3 over 9 is equal to 7 over 21. Does that make sense? Well, 3 times 3 is 9, 7 times 3 is 21. The ratios are the same. So just to make sure, this does make sense. This does make sense. Anyway, okay, now you can go. Bye, peace.